Welcome to June 2025 TriEmbed meeting. Do we have any announcements? There is a design to part show going on in Charlotte this week. It's been in Raleigh some number of years ago, probably before the pandemic, down at the convention center, and I went there, and the thing I recall was going to this one booth that had some 3/4 inch steel plate that they had laser cut a design out of, and I asked them, and they said they had an 8,000 watt fiber laser for cutting their steel. Yeah, so Antonius has a mute thing. Let's see if we can. I can ask him to unmute, and I can mute everybody else. Neither of which, I guess that's good that I can't turn his microphone on. Yeah, so that's in Charlotte. I believe it's the 11th and the 12th, which would be Wednesday and Thursday. I'm pretty sure that it's free if you want to go look.
Yeah, I've been a few times. It has been here in Raleigh in past years, and there's plenty to look at. It is free, and
some neat stuff.
There's an amazing collection of stuff.
Stamped like metal springs and EMI filter things and
metal 3D printers, for example, that are impressive.
Yep.
And 3D printers for carbon. What do you call
fiber?
It? Carbon fiber, some way of forming carbon fiber into
like
arbitrary
shapes
rings
or something.
I saw the clutch handle for a motorcycle, and if you were breathing too hard, it would blow it across the tabletop. It was like
light.
Yeah,
crazy
light.
So you can get. I think that one was nylon with pieces of carbon fiber impregnated into it. I've also seen a printer that has one spool of carbon fiber and one spool of binder material, and they kind of mix them together as they're extruding. Anything else going on?
The ARRL field day is coming up in a week or three. I forgot which week. I think it's the last weekend. And if you were to cruise around a little bit, you'd probably see some activity. Like in Cary, there's usually somebody setting up and operating in Ritter Park.
And what is ARRL?
The ARRL is the Amateur Radio Relay League, an archaic term, for the major U.S. organization related to amateur radio. And every year in June, there is an event that's very oriented towards introducing people to amateur radio. So it's not a contest, but it kind of feels like a contest. And basically, people set up and operate outdoors, set up temporary stations with antennas strung between tree limbs, or in some cases they'll stick like a step ladder, attach a mast to a step ladder and stick an antenna on it and that kind of thing.
Okay.
And it's very much extremely oriented towards anybody walking in off the street, seeing how it works, typically being invited to have a try at talking to people on the radio. It's a fun situation. It runs from memory. I think it's 2 o'clock Saturday afternoon to approximately the same time the next day. I'll look up the date. Anyway, if anybody wants to find out more about it, I'm on the list, or just Pete@Sopert.us, and I can give you information about where things might be going on.
Okay. All right. Well, let's bring up the problem of the month. All right. Am I sharing properly?
Yeah.
Yes, you are.
Yes, you're sharing fine.
Good. All right. June 2025. So I'm using a Shelly One IoT smart relay to control a bathroom exhaust fan. The Shelly One mounts inside of the box in the wall where the switches are, and you rewire some stuff. So instead of one of the switches in the wall controlling the fan, the switch acts as an input to the Shelly, and then the Shelly has a relay that can turn the fan on. And I was looking at the wiring diagram for it, and it had two different things. One for if it was an inductive load, and one for if it wasn't, if it was something like a light bulb. And so I started looking into, let's see. Yeah, so here's the wiring diagram, and they have a RC snubber across the load here. The 0 and 1 or 0 and I on the device here are just contacts on the relay. And presumably the issue is that if you hook up highly inductive loads to a relay, as the relay snaps on and off, you get arcing, and you may end up having your contacts fused together. And so I went to Amazon, and they have a couple of different kinds, but this seemed to be a very popular RC snubber. It has a resistor, a capacitor, and an MOV, metal oxide varistor. Here are some of the specifics of the components from one of the reviewers. It was an interesting note. He says that the MOVs fail as a short, which sounds kind of scary to me. So my question is, should I consider putting one of these things on my exhaust fan? And should it go up in the ceiling where the fan is, or is there a way to put it closer to the Shelly? And am I worrying? I mean, the switch that turns my exhaust fans on and off in my house, been there for 40, 50 years and seem to be working just fine.
but it's not powering semiconductor devices.
What?
I mean,
Oh,
so the hazard that I just read is the spikes can cause the Shelly device to get confused and reboot unexpectedly. So it's apparently spikes getting into the power supply for the control circuitry, right? So
okay.
it's somehow imposing a big glitch on the power rail running the microprocessor or whatever it is, and causing that to malfunction.
So the concern is spikes coming in on these wires.
No, spikes coming out of the motor. So
Yeah.
as you said earlier, when the motor's turned on and off, uh, when you turn it off, the a magnetic field in the motor can collapse and
Right.
cause back EMF at quite high
Right.
voltages. Yeah,
Right.
that's the issue. And
Yeah.
you don't need to worry about the MOV shorting because the circuit breaker in your house will just pop. So, that's not going to cause a fire or anything.
Okay. I mean, these two terminals are contacts on the relay. So um, this is your AC mains, which just also happen to be these two wires. So the motor collapsing can drive a current toward the relay and arc, as so the relay is opening, the motor's collapsing, the spike can bridge that gap. But I guess it can also come in on the line, not so much the neutral, but maybe into the circuitry here.
No, and I think the location of the snubber.
It won't.
If you
The location of the
connect,
snubber means that the collapse will be absorbed by the snubber and never
Right.
see.
Right, right. The snubber is supposed to absorb that spike so that it doesn't go back onto the relay contacts.
If you're worried about it, you could put a fuse, just a simple fuse in the line.
well, if you put the snubber between 0 and 1,
Okay.
it's going to clamp the transient voltages, and the question is how much inductance is in the wiring up into the fan, up in the ceiling, and is that inductance relevant? Why do they have a different? Wait a minute. Did you say at the beginning there's a different wiring for inductive loads or not?
The inductive load wiring includes the snubber. If it's simply a light bulb, they don't include the snubber in the wiring diagram.
Okay, but it's 0 and 1 in both cases then.
Yes. Yeah. 0 and 1 is just a relay. It's the contacts. It's a switch.
Right.
Acts like a switch. Right. You can put 12 volts on that and run a 12 volt device, or a 24 volt device, or a 30 volt DC device. Right. You can run, it says 240 volts on those with a different, 110 over on the other side. So it's an isolated relay output, relay contacts, right?
Well, if the snubber is connected between 0 and 1, the only net effect is that in this diagram, the wiring going from one around, taking the long route, ends up going through that motor. So, the transient's going to show up. And the question is how messed up the snubbing effect would be with the extra wiring that would be involved, which could be arbitrary, couldn't it? That wiring could go to the far end of your house and back, but
It could.
If I were running a 1 horsepower washing machine motor, I would worry about it. I wouldn't worry about a 1/10 horsepower fan.
Okay.
yeah, I mean,
So the fact that it's across the motor, you're saying is not critical?
it's hard to guess how critical it is. I think Nick's point is that the let's call it the strength of the transient is probably not going to be very big compared to
Because it's a
on
small
Yeah.
small motor.
On the other hand, yeah, but when we're operating at low voltages, we've probably all dealt with relay connections, right? Like DC relays and
Yeah.
stuck the obligatory
Put a diode
rectifier
in.
backwards, across
Yeah.
the coil.
Yeah.
And this is a similar situation.
Okay. It can't be a diode because this is AC potentially.
Right, which and so the MOV now the fact that the MOV is triggering up in the almost 500 volt range is kind of bizarre. I don't I guess that's peak to peak. So so if the appliance was 240,
It's not. It's 110.
no, right. But if it was, I'm trying to understand why they would have a 470 volt MOV on it, and it has to be the fact that it's you don't want it clamping, chopping off the peaks of the AC,
Okay.
which are higher than 240. The 240 is RMS, right?
Yes.
Yeah, the fan, I guess, is 110.
It is.
Yeah.
Definitely
You
110.
said that. Yeah.
Is this a ceiling fan or some other fan?
This is an exhaust fan in a bathroom.
Right.
Yeah, I can't imagine that drawing too much current.
No.
Yeah, I mean, it would be less than an amp for a 1/10 of a horsepower, wouldn't it?
Yeah. I would imagine.
And it's not triggering once every 2 seconds. So, and is it a physical relay in there, or is it a SCR?
I can hear it click, so I believe it is a physical
Okay,
relay.
physical relay.
And I think I remember seeing something that said it is dry contacts. If that matters. Not that I know what wet versus dry contacts are.
Mercury wetted relays are used for very, very low impedance. Use them in test circuits.
This might be a use case for your oscilloscope. You should be able to see this misbehavior and
I have not hooked up my oscilloscope to AC. I don't know that I have probes that are rated My
Yeah.
input
Yeah, I'm
has to
not.
be,
Yeah, you don't want. Yeah, one of
don't
those
want a fried
USB toy
smoke.
ones might blow you up.
yeah. Yeah, it would be interesting to see on somebody that knew what they were doing better than I do. All right, any other comments
Do
or
not hook.
insights here?
If you hook up your oscilloscope, do not hook the ground clip to one side of the AC. Run the thing differentially. If you hook the ground clip to one side of the AC, which I have done, then it's bad.
I've done it too. You'll learn not to do that.
Yeah, don't do that.
Don't do that. Differentially. So where do you hook it? You got,
You have two probes. If you want to look at it, you hook one probe on one side and one probe on the other side,
I see.
and then you put an add subtract. There's a but
Yeah, the right. What
I
what he's saying
I
is that the other side
unless you
is on.
want to see big sparks,
What? Yeah, what he's saying is
do
that
not.
yeah, one side is frame ground. I mean, it's the house
Ground, yeah.
neutral.
Yep.
Yeah.
So if you put that on the wrong side, you're basically shorting the AC, and you'll probably pop a breaker.
You'll probably pop your
So
oscilloscope.
if you hook the ground to the line, to the hot side, is that what you're
No,
saying?
if you inadvertently put the hot side of the AC
On the
on
ground
the
of your,
ground side of the scope, yeah,
yeah,
that's what we're
that's
talking
going to be
about.
bad, right? Yeah.
Yeah, don't do
That's
that.
bad. Having done
When I
it,
did it, I think I blew a fuse in my oscilloscope is what happened.
Oh, right.
I think that's what
yeah,
happened.
don't. It is the snubber. If you're dealing with like a 10th horsepower fan motor, I don't think the snubber is necessary, but it's a belt and suspenders thing. It can't hurt.
Yeah.
And if you really want to go belt and suspenders, then put an inline fuse. But that's overkill. If lightning hits the house, then that's the least of your problems.
That's the least of my problems. All right. Well, it sounds to me like I'm fine without doing this since it's a low inductance type motor.
And I think if you have problems, then the next experiment is to stick the snubber between 0 and 1.
Okay.
Don't
Buy
join
the
it to the
snubber
ceiling.
and then put it between
Well, we
0
could
and 1.
build one.
We could build one.
I don't have any. I've got a lot of MOVs, but I don't think any of them are that high voltage. I tend to use much lower voltage ones.
I have a baggie of MOVs that was in my father's workshop from
Yeah.
way back when. They're probably 35 years old now. Okay. Any other comments? All righty. Thank you. Show and tell. I'm gonna start. I don't remember if I told you guys a month ago about my next project. My daughter sent me a picture. I should be able to find it. And said, it would be something kind of cool for the kids, her children, my grandchildren. So can you see that?
Yeah, you did mention this, right?
Yeah. Okay. Yep. All right. So she says, something like this. She doesn't want it mounted on the wall like this. She's thinking more of a sandwich board kind of a thing, or a paint easel kind of a thing, which has some manipulatives on it. And she said I could hook up Arduinos and do sounds and lights and things like that. So here's my first thought that I've been working on. So these are some 3D printed gears. And I'm gonna so here it is. If you look at my picture rather than my screen, so these are, I got to use a bunch of different colors of filament that I had. And I used OpenSCAD to design the gears. And there was a parametric gear function that you told it the pitch of the teeth and how many teeth you wanted around. And so the Arduino aspect, let me go back to my pictures here. So my 3D printer has 2 extruders. And so I can do multiple colors, 1 or 2. And so the blue gear has these 6 black spots embedded within the plastic. And on the back of my board here, I have this little guy, which is my line sensor from my SumoBot. And I can detect when the black spots go over the line sensor. And so I can count spots, and I know how far and how fast the rotations are going on the set of gears. And my thought here is to use the rotation speed to adjust the tempo of playing back a song. If you think of, I can remember from childhood a Jack in the Box that played Pop Goes the Weasel, and it had a little hand crank. And if you would spin it faster, the song would go faster. If you'd spin it slower, the song would go slower. And so that's kind of what I'm aspiring to at the moment. I have been working on audio a bit. I purchased a little MP3 player, playback board that you put MP3 or WAV files on an SD card, and you can either have a push button interface which goes forward or reverse through the songs, or there's a serial interface that you can select which song to play. And it took me a little while to get that working, but I did finally get it working. Not all of the WAV files that I downloaded are playable. That confused me when I tried to do things, and I'd try to say to play it, and it wouldn't play. I also bought an I2S microphone. I'm thinking I might want to do some sampling of the kids' voices and whatnot and play them back. I got that working. I bought a little I2S amplifier that drives a 3-watt speaker. And I got that working. Let me, I'll get it booted here. So I found really simple sketches that so I don't know if I'm going to move my microphone near the speaker here. So that was a streaming radio station from the West Coast somewhere, or maybe it's in Europe even. There were a variety of stations I could tune to. Um, so that part's working. I tried to generate my own sine wave to play back so I could do just generate some tones and have that come out of the speaker. I had mixed success with that. If I had the sine wave exactly fit some integer number of repetitions in my buffer that I told the device to play, I was able to generate a tone. I was not able to, so if it didn't match perfectly, then I would get a big discontinuity, which was a crack or a pop or something in the speaker as it went from one buffer to the next buffer. And so I'd get a big buzzing sound. And you could barely hear the tone that I was trying to get. Most of the libraries I've found will play back WAV files or MP3 files. The ones that you give it a buffer of samples, my issue with them is that they're blocking calls. So you give it a buffer and it blocks and until all the samples get sent out of the to the speaker, and then it says, okay, give me your next buffer, which is fine if you've pre-computed them. But if you want to generate tones and music on the fly, you need a non-blocking so that while one set of samples is going out, you can be using the processor to compute the next set of samples. Nick, you told me about the ADF.
A something F, yeah.
Yeah. And I looked at that. There were some samples, some sketches, examples, whatever, that kind of talked about how you might be able to figure out what the address of the DMA buffer was. And I was able to get a callback to fire when the DMA buffer was exhausted. But as far as having a nice non-blocking interface, I haven't discovered that yet. I'm sure it's doable. I'm sure the low-level stuff that all of these libraries are doing is, they know where the DMA buffer is. That there's hardware on the ESP32 for doing all of the work. They're not having to bit bang the I2S interface.
I was going to ask is, so it is the ESP32 that you're using. Does it have an I2S peripheral built in, or?
Yeah, it has. The one I'm using has two I2S hardware interfaces, so that you could potentially be doing input and output simultaneously. Some of so that's the kind of the original ESP32. The cheaper ones only have a single I2S interface, which is probably fine for what I want to be doing. I don't think I need in and out at the same time.
I don't have any kids. I don't have any grandkids. However, I would hook magnets into the little wheels and run a Tesla coil.
A Tesla coil.
Yeah, you get big sparkies.
Okay. You're muted, Carl.
I said that would be a shocking experience for the kids.
Yes.
Yeah.
I made a Tesla coil for high school science project.
Antonius, we hear some noises.
Yep.
It's not intelligible.
I hear some noises.
You're getting better.
It's not
Yeah. You got too much gain on your mic somehow.
I have a 4-foot winding for a Tesla coil. I could get some really nice sparks.
Yeah, I had one that was about 4 feet high, and
Yep.
the diameter was probably, I don't know, 8, 9 inches.
really nice spot.
And I wrapped very thin wire from the full height of it
With the
up
diameter
to like a nail or something that came out of the top. And then I had a really thick wire around the bottom. So essentially I made a transformer.
full height.
And when I fired this thing up, I could hold the fluorescent bulb in one hand and put the other the other side in the arc, and the bulb would light.
And when I fired this thing up, I could hold the and the other side in the
Oh, that's Carl.
That
Carl
is me.
is. You're feeding back through Antonius's microphone.
Or vice versa.
Oh, that's Carl.
That's me.
Yeah, that's you.
Oh, we should charge extra for this YouTube.
That's you.
All right, I'm going to. Oh, now he's muted. Okay, that's better. Yeah. Okay. So that's it. It's coming along. I'm doing some design work for the stand. My wife thinks it needs to be bigger so that I can have multiples of these boards. Multiple activities simultaneously, so that 2 kids don't whack each other trying to play for the same one. But even if you give them 10, they're all going to want the same one. If anyone has ideas of other toddler-friendly things to hook up other than Tesla coils, I think I'll pass on that one.
I was wondering if you could maybe break a light beam with the gears. And I mean, unfortunately, they're all similar size, but if you had little ones and big ones, somehow made something that was changing at the rate of the gears, to show that like this little one is going really fast and this big one that you're cranking with your hand is, I don't know, just a thought of leveraging the movement of the gears, and the different ratios and stuff.
Yeah, the gear library, I guess, even rightly so, has a limit to how small it will go. I would have to change to a finer pitch to get quite small gears.
But you could,
but it doesn't. Okay.
You can put a.
Go on, Pete. I was
just going to say you had them not quite ganged together, right? I mean, where only one of them, right? So
these 3 go together.
Right. So the green one, I mean, if the blue one wouldn't have to be terribly small to make a difference. I mean, it would still So if it had, it looks like what, 15, 16 teeth, and if
Yeah,
you could get it down
it's
to 10 or 12.
15, 18, 24.
Uh-huh.
Like,
And
I
there's
just
a
say
limit
that,
to about, I think 12 is the smallest
right.
that I can go.
But if you, yeah, with 3 in a row though, I mean, you've basically got 2 opportunities to scale it up. So anyway,
I mean, this isn't, we don't have a big gear attached to a small gear so that you can gang them, right? If you
I'm
go
saying
real big, they,
yeah, to the effect, to the extent that the blue gear could be smaller, it would multiply twice, right? I mean, it would. Oh no, it wouldn't. I'm sorry.
no, it doesn't.
You
Yeah.
need. I'm sorry.
You need
What am
the,
I thinking? I
you
don't know
need
what I'm
this,
thinking.
you need the stacked gears.
No,
There's a name for,
you need a smaller and then a smaller to
yeah,
get
yeah.
what I was trying to describe.
Or if they're stacked together so that
yeah. So a 24, if you turned the 24 and it was connected to a 12, the 12 would turn more or less
twice as
twice as
fast.
fast as the 24.
Yep. But then if you go back up to an 18, you're now at 1.5 or 3/4 or right. So
Anyway, I was thinking of something else that you could make.
okay.
So you know those things on the bottom of garage doors? So if it's a light beam that goes across the bottom, and
Yep.
if you interrupt the light beam as the door is closing, it'll automatically open again.
Okay.
Well, you can put something like that on the board, maybe 6 inches apart, that goes into an Arduino somewhere, and based on maybe some presets, every time they stick their finger between the two things,
Great.
something
Great.
fires off, or a buzzer sounds to annoy their mom. Something like that can happen.
Okay.
And that would be relatively safe.
Yep.
No
Yep.
sparks involved.
Right.
And the the gears breaking the beams could maybe translate into sound.
I mean, at this point, I know how fast things are turning, and the level of dexterity of a toddler. I think you have to make a big difference for them to appreciate.
Well, he could be working on his PhD.
So so I think I have everything I need to gauge how fast things are spinning. So making that more accurate, I could print finer dots. I could put 2 in and do like a rotary encoder to see whether it's going forward or backward.
One of those Adafruit LED discs might be nice on one of the gears. So as the more you turn it, the LEDs do things.
That's kind of cool. Yeah, I have one of those. I could print one of these gears with holes and shine the light through the gear. Okay. And it doesn't have to be gears, right? I mean, if you remember that whole board, there were shapes that go on pegs and beads that slide along wire pathways, and the ESPs are supposed to have good capacitance sensor circuitry built in. I haven't used that before, but that might be something I've thought about. Kind of like whack-a-mole, where you've got some lights and the light lights up and the kid swats at it. Swatting might be fun for a youngin. You test their reaction time, and
Or if you put one of the LED discs on, you could have them do 6 turns to the right and 3 turns to the left, etc., which would give them, some sense of coordination when they can count.
yeah, you have to instruct them on what they're supposed to do by playing a wave file or something, and then praise them with lights or whatever sounds as they're accomplishing their task. All right, who else has something I want to talk about? Well, I can show another another 3D printing project I did recently.
Another 3D printing project recently.
Okay, who opened the helium container?
That's Antonius. It's that was me talking, somehow being transmogrified on his end and retransmitted through his microphone. So this is a hole in some T11 siding, one of the horse turnout sheds at the horse farm where my wife has her horses. And I had to drill a hole that big to get the plug or the outlet through the hole. And I didn't really want to have that as my finished product. Critters can get in and out of that, although there are plenty of other places that they can get in and out of. So there's my little 3D printed doodad that fills the hole and allows the cord to come out. This is a picture of it on the inside. And so there's a lip on the back that keeps it from falling through. The weight of the cord keeps it somewhat tight in the hole. And then there was a slot here, and I made a little plug with some slots inside that this key slides in and holds the cord in place while it's sitting there. I think that looks really nice. I'm really happy with that one.
What software did you use to design that?
So I use OpenSCAD,
Yeah.
which if you're a programmer,
Oh yeah, I'm familiar with it. I've done stuff with it. It's
OpenSCAD's pretty cool.
Yeah, I've used it before myself. It's kind of like a mixture of C and
Yep.
whatever.
Yep.
Except there's a difference between functions and modules.
Oh, there's some using a thing and importing a thing, and
Yeah.
they work differently, and yeah. Yeah, so Antonius asked, he'd never heard of it. So it's based on constructive solid geometry. I can bring up I'm not sharing now, am I?
No.
Okay, let me. So this is OpenSCAD. This is the gearboard, and so you do your modeling in a text editor,
Yeah, you can actually use an external editor also, but you can't test right away, right? You'd still have to load it to test.
I'm not
You
totally
can,
sure.
because I think I've scripted it before, so you can even
Yeah,
run
I've
the
actually
script.
done it. I actually wrote some stuff in Emacs and then imported it into OpenSCAD. So
Yeah, so this object is a union of two cylinders followed by a difference of that union with another cylinder. So this one is the drills the hole in the middle.
the translation is what moves it.
Yep.
What does the percent sign do?
It highlights it in this
Oh, really?
gray, and there's also a sharp which highlights it in pink. I forget. There's different terms that it uses for the highlight versus the identify.
There's a cheat sheet, I think, in the help that's like
Yeah.
really good, that shows you all the like all the
2D and 3D operators. So there's circles and squares, spheres and cubes, cylinders.
I do have something. I'll be right back.
Okay. Transformations, union difference intersection, the math functions, and then there's some weird ones. You can do looping and whatnot. And there's some weird ones like Minkowski, convex hull.
Convexity.
So Minkowski, you take two objects. So you can take this. It's an expensive operation.
So what did you do? Create a namespace with module dot?
And this defines a function. This module defines a function, if you will.
But what's the dot?
What dot? Oh, I have white space highlighted.
Oh, okay.
I'm sure there's an easy way to turn that off.
It was confusing. I thought it was like a dot separator on like a class object or something.
No. So without looking up how to do this right, I'm going to try this. So Minkowski takes two objects and runs one of them all over the other one and gives you the result. And I don't remember which way is which. So I'm hoping that this gives a 0.3 millimeter sphere run all over this yellow part. Or it may be that bushing run all over a 3 millimeter sphere. But you can use it to make fillets and rounded edges on the bushing is the thought. But it has to do all this running one object all over the other one.
Brother, that is compute intensive.
Yeah. So you don't do it too much.
Wow, it's taken a while to resolve there, huh? Yep.
Yeah, I forgot. I found something that I did a few years ago in OpenSCAD, and it's a weir for my my marine saltwater aquarium that sprang a leak a few months ago and is no longer running. But
Yes, that may, I don't know which way it's wrapping. I guess I could go check the cheat sheet.
It doesn't seem to have the busy bar at the bottom anymore.
Oh yeah, it's there. It's still at 999 of 1,000. So usually it gets to that point and then does the remaining 80% of the work.
Yeah, you had it below
That's
the other thing.
the 80-20 rule in reverse.
That's right. Yeah, in the
Incredible.
first. So I do have them in. I do have them in the right order. And so,
So,
this should,
so SCAD's written in COBOL, huh?
I don't
How
think
can it
it's
be that
so
slow?
Well, it's having to solve the, sum of that sphere on every possible point of the bushing and getting the, the convex hull of an absurd number of little spheres placed all around.
What's the CPU on your computer right now?
Oh, well, let's take a look.
6502, I think it said.
Yeah. I was going to say running at 1 megahertz.
It's only using 13% of the CPU.
Oh, an 8700. That's not a bad chip.
Yeah, it's an i7 at 3 gigahertz. Oh, I think that bloom meant it was done. Yeah, so look at that.
I'm impressed.
Okay, so it smoothed over those edges, and it actually increased the size of everything by 0.3 millimeters. And so you have to be careful that you model everything smaller so that when it gets bigger, it ends up as the right size you want. But so you learned something new about OpenSCAD. Now let me get rid of that so I don't accidentally press that again.
Yeah, I have a design I could put up if you were interested.
Go for it.
Let's see if this is the right. Is this screen? I have 4 monitors, so I'm trying to figure out which is the right one. Let's see. No, that's not it.
So while I was designing my spots on the back of the gears, I had to think, what do these different colored 3D printer filaments look like in infrared? And I had no idea, right? So I used that sensor and actually sampled each of my spools different colors to see how much they reflected. And it turns out black reflected less than most of the other colors. Okay, so that looks like a little
Yeah. So
strainer kind of a thing?
it's it's called a weir. It's like so basically it sat on top of some PVC pipe.
Yeah.
And there was a pipe that went through the center of it, and it creates a little it's called like an overflow for filtration for my saltwater aquarium.
Okay.
So I designed it. Well, I designed it myself, but it was based on a lot of YouTube videos watching of people who kind of figured this out. But I wanted something that was silent, so I wanted something that water could kind of fall into. And then when it falls to the bottom of that, there's a siphon that kind of pulls it out of the tank, and then underneath the tank there was a filter, and pumps water back up. But I played around a lot with. I kind of made these like parameters where I could, like this shelf offset, which is the I have this little shelf right in there, so it's sits on top of the PVC pipe. So that was
Right.
matched to like the outer diameter. And then the other thing I did is I wanted these things, these little slits, as large as possible to let more water in, because the original one I made, that I guess you can't probably see me right now, but it was too narrow because I didn't want creatures to be able to get in there.
Okay.
But what happens is when algae and crap, this tank was a bane of my existence. It always was full of algae, and it would get loose and it would get clogged. And then when this thing would clog up and it wouldn't flow, the filter underneath would start, it wouldn't get sufficient water and it would start sucking air. And it wouldn't hurt it because it was designed to be able to, the pump was designed to run dry. I mean, it had safety mechanisms so that you wouldn't hurt it, but it was noisy. So I didn't like all the noise. So I had to, after it was running for a couple of years, I actually did print another one. I can stop sharing now and just show my screen. But I printed another one with the larger size. But then there was one evening I happened to be in it's in the room I'm now where I have like 11 fish tanks in here. And the saltwater one was, I heard some noise coming from it, which wasn't unusual. But then, so I started walking over to it because I thought maybe something was clogged. And then the lights started dimming. And then the noise was actually a buzzing. And what had happened was it had sprung a leak, and it just happened to drip on the power strip that was right below, powering half the equipment. And saltwater on a power strip, they don't get along. So I had to unplug it, and that was it was kind of a stress. Of course, it happened at like 10:30 at night, and it was 70 gallons of salt water. And what I basically figured out, it was leaking from beneath it. And I was like, I'm going to have to tear down the entire tank. There's nothing I can do because it's underneath of it. But it's a slow enough leak that I have a bunch of spare tanks. So I put a tank below where it was dripping just to catch it. And I'm like, that'll be good until the morning. And then I had to take the day off of work to deal with it. I had to break it down. It was like a whole day thing. And I just never put it back up because it was, like I said, that tank was a pain. But I did, being, as part of this group and getting into fish stuff, I have tried to do some kind of DIY, hacking stuff. And kind of like the people who kind of frequent TriEmbed in the fish club, there's a lot of one similarity is that we're a cheap bunch, right? We like to DIY and we like to do things cheap. So there's a lot of people, trying to come up with their own, little clever things for stuff. I think that might be part of why I like that group. But
does anyone do continuous pH monitoring?
We've talked about it. pH is hard because you need chemicals. It's usually done with a solution. You put some. I don't even know what the chemicals are, but it's a color change kind of thing, or it reacts. And
there's litmus paper, and there are inline pH probes, but running them continuously. I've got a couple here.
Right.
Yeah,
but they usually
normally they sit in a buffer until you want to take your measurement, and you put it in the measurement, and you take your measurement, and then you're done, and you have to put it back in the buffer to get it reacclimated to.
Right. Yeah, and it's a lot of them. The probes. I mean, they're super expensive, but they also have a lot of them consumable. Like you have to replace
the platinum tip or something.
Right. They don't last terribly long, so I think it's not as common. I mean, things like temperature, definitely people. Temperature is a no-brainer.
Would continuous salinity monitoring be of any use to you?
No, I mean, that one would be an easy one to do. However, the salinity is usually not something you worry about too much. It is what you, when you put water in the tank and you put the salt and you put them in the right ratio, you're usually good after that. It's not going to change. It's not going to, it stays pretty stable. I mean, you top it off with distilled water,
Okay.
And my saltwater tank, I had to do that. Once it evaporated enough, it would start making noise. It would start sucking air. So I always had just have a RODI, a cheap RODI unit that I keep a bunch of water jugs, and I would just top it off whenever it started making noise. But I would only really check the salinity on, brand new water when I'm mixing up, doing a water change and making a bunch of new water to put in. Or I take it back. I do have a tank of shrimp, these Hawaiian shrimp that are brackish, so they're not full salinity. They're actually like a third, I think, of ocean water salinity because they're from Hawaii and they live in the lava tubes that mix natural springs mix with ocean water that come up in the lava tubes, and so that they have not a full salinity. And for those ones, I will. It's more of a pain. I do a lot of measuring the salinity to get it right because they're also shrimp are a little bit more picky about water conditions. So I try to get it as close as possible. But yeah, it's that hobby's kind of kept me busy. And actually, in the pandemic, I sort of went a little crazy and got really into it. And I'm on the board of that club, so I go to the monthly meetings and the monthly board meetings and help run and plan expos. So that's part of what I've been up to for the past few years. So
I have a 20-gallon tank, and my plants do really well. I have Java fern and Java moss, and
Yeah.
my fish do really poorly because I let the pH slowly go down to 6 point whatever, and all the fish die. And I say, oh, well, maybe I should see what the pH is.
Yeah. Crushed coral is your friend there. You put crushed coral in there in the filter, and it'll dissolve. It'll buffer the pH from falling too low. So I didn't mean to hijack this.
It's as you say, there are a lot of overlap, and
yeah, it's science. It's more science stuff too. It's so
right.
I'd like to share something about SD cards that I discovered and pick your brains. Can I do that?
Yeah,
Sure.
Okay, so I was bringing up a new Raspberry Pi, and for the first time since the pandemic, I fetched the OS image and was going to flash it onto an SD card. And I have this habit of just blowing away the SD. I don't want the SD card's partition table in my face when I'm looking at it or whatever. In any case, I DD dev 0 on top of the SD card like I've done hundreds of times, not just SD cards, hard drives, everything going back decades, right? And I did that, and then I DD'd the Raspberry Pi OS image onto the SD card, not paying any attention to whether it had an error or anything. I don't remember even looking. It's like, okay, it's DD's put something out, so it must be finished. So I grab the SD card, stick it in the Raspberry Pi, and I get for the first time since I've been messing with Raspberry Pis, and which was like April of 2011, I was an early adopter. It didn't come up. It's like I've never seen that happen before, and the system wouldn't boot. So anyway, I take the SD card back to the laptop, and it has suddenly changed itself from a 32 gigabyte SD card to a 6 gigabyte SD card. And I'm absolutely perplexed, and I notice, and of course, I can't leave the damage to just one SD card. So I grab a 16 gig SD card that I've got, and I try sending a bunch of zeros to it with DD. And at 6.1 gigabytes, the DD fails. And when I go in with FDisk, FDisk is reporting I only have a 6 gigabyte SD card. And I'm getting a little bit upset because I will confess that I asked ChatGPT what the hell's going on, and ChatGPT says, "Well, this could be a counterfeit card," and I'm off to the races because these are cheap shit cards. They're no names.
Yeah,
I couldn't have grabbed, I couldn't
I've
grab the Samsung.
I've
I
run
had to
into
get the
them.
no name. Okay, well, that was
Yeah.
a red herring.
Right.
I rebooted my Linux laptop and everything was suddenly sane again. The 32 gig SD card was a 32 gig. The 16 was a 16 gig as reported by FDisk. Has anybody seen anything like that behavior ever?
Yes, and it's as mysterious for me when that's happened, and it's
Okay.
on Windows, Mac, and Linux. None of them all of them seem to once in a while get weird with SD cards specifically. I
Okay.
don't know what it is. So,
Well, I feel a lot better knowing that it's, it wasn't picking on me in the
yeah.
whole universe. Yeah, so I had never seen anything like it. Although I will say, um, USB and Linux. I can't describe the hassles I've had with USB and Linux, and
Really? In what sense?
it's in the sense that maybe it's fixed now, but when I first started messing with Raspberry Pis, I once spent a good portion of a summer rebooting my goddamn sorry about that, folks, rebooting the computer to get the USB subsystem working again. And that didn't particularly involve SD cards. That was more like JTAG, debug interfaces, serial interfaces to monitoring the serial output from a device or whatever. But I've just found kind of chronic instability with USB and in various circumstances, and with more recently with the ESP32. It's like, how come part of the time, it's not behaving?
It's
not
those
cooperating.
it's those interface chips, right?
What version of Linux are you using?
Oh, at the moment, I'm using Ubuntu 22 on most of my machines, but this goes back a long way. I was probably using 14,
Yeah, that's a
when I
while ago.
started on this stuff. But
Stuff has greatly
anyway,
improved over the years.
it has. I think it's up to 2 nines, maybe 3, in my experience. It's just
Yeah, I've had problems with.
anyway. That's all I had. Thanks for the commiseration.
I was looking at my box of sensors, which is overflowing with goodness, and I have a dissolved oxygen sensor, if that is a good thing to have for at least fish. I don't know about fish. I only eat them.
It would be it would be neat, but I don't know if I have had problems where I'm pretty sure the oxygen with planted tanks, the chemistry is fascinating, but usually lack of oxygen is not. If it's a problem, you know it. You have ways of knowing it. A lot of people use. I don't, but a lot of people use CO2 for plants. There's a lot of plants that won't do well in a tank unless you do CO2 injection, and that's fish and animals are not big fans of having breathing a lot of CO2. So there's always a balance with that, but overdosing with the CO2 is usually more of a problem than the oxygen. But it depends. As long it's an easier. Like I said, it'd be a neat thing to see and know, but I don't know if it would be practical of use. It's not a common problem to run out of oxygen, but it can happen. This one tank behind me, which is in pretty bad shape right now, so I'm not going to unblur. But sometimes
blurred out anyway.
Yeah. Sometimes the plants will cover the surface, and they've done. And I used to have like 200 fish in that tank, not because I put them in there, but because they just were very prolific and would multiply until they were overcrowded. And a couple times where overnight there'd be some dead fish in the morning, and usually at night the oxygen goes down, because the photosynthesis stops, and if you have floating plants that are covering the surface of the water, that's the oxygen isn't getting in. They're blocking the oxygen from getting in there. But yeah, it would be interesting thing to know too, and especially because it's counterintuitive, but the oxygen levels are inversely related to the temperature. So warmer water can hold less oxygen than cooler water. So it's neat in that sense, but it's not something usually people worry too much about. As long they make sure there's flow in the water. And as long as you have flow, you're going to have enough oxygen. Usually it's the buildup of like ammonia and nitrogen, nitrates. Those are like the big fish killers.
Yep.
I've looked into how to try to come up with continuous monitoring for those, because that would be really cool. And there's I've had this idea. There's like absorption profiles.
Yep.
For different parts of the spectrum, and usually most of them for the nitrogen profiles are they're in the UVC range, which is not a fun area of the spectrum to work with.
I've got 4 or 5 spectrometers, probably more than that, ranging from infrared at 1600 nanometers down to 100 nanometers, quite a range. And all sorts of probes.
I think that's UVC, right? 100 nanometers.
Right. Yeah, I go down to 100 nanometers.
Yeah.
I have continuous spectrometers that go down that low, but you're probably. But I have all sorts of spectrometers for various frequencies. So I hadn't thought of fish as an application. Let me think about it, and I may have a solution for you.
Oh wow, yeah, that would be. And I've looked up like the absorption, and I think for some of them, there's some overlap. So you have to have multiple. You have to use a little
Yep.
logic.
I'm designing a detector for a particular toxin in peanuts, which involves certain select frequencies, an aflatoxin, which is a carcinogenic mold that grows on peanuts, and I'm playing with detectors for that.
Oh, that's cool. Yeah, the ammonia, is a nitrogen, compound that's a big fish killer. But ammonia has two different forms, different ionized form, and
Yep.
and it's strongly correlated to the pH of the water. And so to test for it, when you use the little kits to test for ammonia, what you usually have multiple droppers of liquid that you put in your little test kit, and the first one is usually something to peg the pH to a specific, to force all the ammonia to be the one ionic form of it, and then the other reagent is something that turns color based on it. But if you were just doing a continuous tester, you might have to be able to test for multiple types, the forms of ammonia in the water.
Yeah, I may have a solution for you.
So
I have.
you're gonna fish for a solution?
Yeah.
Sorry.
I have much money invested in spectrometers.
Well, yeah, I looked at that, and also, I had ideas in my head for you need an LED that would at a specific wavelength.
Yep.
And
275, I would think 275, 265.
Yeah,
Are
and
generally what you get.
those are scary frequencies to have emitters. I have a UVC sterilizer, and I've only turned it on like twice because I was going to build my own filter. But it's kind of
265.
Oh, cool, yeah. I think it's the two.
And I've got multiple frequencies.
The UVC sterilizers, how they work is they're just the right frequency that they can break the DNA bonds in cells.
Yep.
So and they don't actually kill the bacteria. They just disrupt their DNA so that they can't reproduce. They become sterile. But they don't. They're not. It's not too. It's not too kind to human DNA either. So.
I have welder's glasses.
Yeah.
So, it's yes, it's not good for the eyes either.
Yeah.
Let me look at what I can do for fish. So I've been focused on this this toxin for peanuts, but I think
Yeah, so there's the whole nitrogen cycle. Right, there's an ammonia thing, and then it goes to nitrates, and then it goes to nitrites or something. And
right. Yep.
so you want to know where and what the numbers are for a number of those compounds.
Oh yeah,
It's the saying we have like in fish is that we don't take care of the fish, we take care of water, and the fish just live in it.
I don't do living things, but I spent many years doing photosynthetic research and fluorescence markers. But I'm not allowed anywhere near anything living.
Yeah.
Witness my Tesla coil remark.
Yeah.
Well, your dog is still alive.
Yeah, it's yes, she is. But at UMass, I had 40 acres of soy and 4 wonderful greenhouses, and the agronomist working with me wouldn't let me anywhere near the greenhouses because I killed plants by, plants. I was where plants went to die.
I'm pretty good at killing some plants, so I can empathize.
I killed an air fern once. No,
My
no joke. It
technician,
turned up brown.
my technician one day came in and spray painted the plant somebody had given me years before green because it was just a set of twigs coming out of a pot, but they nicely spray painted the green for me.
All right, anybody else have anything?
I have a random question. Having been
Okay.
here for a while, is this is it typically a remote meeting, or do you guys have a?
So January, February, March, April, those 4 months, we met in person at the Forge Initiative in Morrisville, I guess, was where they were. Their lease was up the end of May, and they're looking for a new place. They're willing to host us once they have a place.
Oh, okay.
So we went back to virtual. Last month we were gonna meet there, but the email blast to tell people when and where to meet didn't go out, and nobody caught it till the day of or something. And so we met virtually last week, and this month.
Antonio is asking
Last month.
I was going to follow up with what's going on with state.
Yeah. So when the pandemic started, we stopped. We went to virtual meetings, and so we have not met at state since 2019 or early 2020. We still have contacts there, and we probably could resurrect that as a meeting place.
My the fish club, we meet at the state at the vet school, but we kind of have a symbiotic, like we we're a paid club and we have a lot of revenue streams, and so we give a lot to the school. We take care of their fish tanks, we buy equipment for them and stuff. So it's they don't charge us to use the space, but we try to give back to the kind of thing.
All right. Any other questions? We ready to go? See you in a month. Everybody have a happy 4th of July.
See you back for welcoming me back. So
glad to see you, John.
Good night. Good luck.